Hi there, and welcome to another Petty Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And in this lesson, we're going to be looking at the domain of a function. Now, in lessons 1 and 2, you looked at what a function was and the notation used to represent a function. If you're still a little rusty on those, I suggest you go back to the lesson 1 and 2 videos before you continue. Otherwise, you're in good shape and we're ready to go with the domain of a function. So the definition of domain of a function says the set of all inputs, or as we know them as x values, of a particular function. So every time you hear the word domain, you want to think of x values. It's the same, it's all of the x values in that function. Same thing. Exercise number 1. Let's consider the function f of x equals 2 times x. So what numbers are you able to substitute in for x to get an output? And it could be any output as long as it is an output. And those numbers are called the domain of a function. So for example, can you substitute in 3 into that function? Could you get an output if you got 2 times 3? And the answer is yes. You'd get f of 3 is 2 times 3 is 6. So pick another number. Okay, great. Now substitute that into the function and see what you get as an output. Did you get an output? Awesome. Try another number. All right, try that one. Put it in for x right now, multiply it by 2. Great. Now let's try a decimal. Are you able to substitute a decimal in for x? Let's say 5.5. And 2 times 5.5. Will we get an answer? Will we get an output? Sure we will. We'll get f of 5.5 is going to give us 11. What about a negative number? What about f of negative 1? We'll get 2 times negative 1. Will we get an output? And the answer is yes, we will. F of negative 1 will give us negative 2. So all of the numbers that we're able to substitute in are called the domain of the function. So what numbers are we able to substitute in for x? We're able to substitute in all real numbers. Every real number we're able to substitute in for x and get an output for f of x. So now in part B, it says write that domain, write all real numbers as a compound inequality. So if we remember from compound inequalities, that's when x is going to be in the middle, and we're going to have inequalities on either side. And if it's all the real numbers, what's the smallest value that we start at, and what's the greatest value we go up to? Well, if it's all of them, that means it's going to go all the way up and approach negative infinity. It's going to go all the way up and approach positive infinity. And remember, you can never be equal to infinity, so these inequalities are always just less than, not less than or equal to, because you can't be equal to infinity. And now it wants us to write that domain using interval notation, something else we talked about in previous lessons. So interval notation is when you use the parentheses or the brackets, and since we're not equal to here because we cannot be equal to infinity, we're going to use parentheses, negative infinity, comma, infinity, with another parenthesis. And these two things mean the same thing in parts B and C, just one is written as a compound inequality and the other is written as an interval. So in this exercise, we have looked at a linear function of f of x equals 2x, and we saw that the possible inputs, or our new fancy word, is domain. Our domain of this function is all real numbers. If this video was helpful, please give it a thumbs up below, and you are ready for exercise number 2. Thank you for watching.